The last topic of this chapter is the standard, or we say standardization. The main purpose of standardization can be summarized means to achieve technical interoperability and replicability. So standardization of different types result in technical standards that are among the involved parties. So that's how it defines standardization. Okay, we mentioned two words in the previous slide: interoperability and replicability. So what do they mean? Basically, that's the purpose of standardization. Interoperability implies that different systems or subsystems they are developed. So take it, it's like let's use Bluetooth as an example, right? So I have a mobile phone, Apple phone, to play music with my wireless headphone. So it's from an unknown brand. So actually, I don't know what brand it is. So they are from the phone and the head, basically the mobile phone and the headphone are from different manufacturers, different to the Bluetooth, actually, which is a protocol and also a standard, right? So the two products can hit with each other and realize their function, probability mean. So for example, in an IoT solution, we may have the devices, the sensors from different manufacturers, and different devices from providers. And for example, we may be using different databases from different providers for some reasons. So we want to reach a functional solution. So we need the interoperability of all these items so that they can work together. A benefit is that standardization and it's a move away from customized solution from single supplier. Basically, interoperability can be achieved at different levels as well, synthetical and semantic. These terms are a little bit professional, but yeah, have in mind on this. Okay, how about the replicability? Is that the solution can be replicated and used in multiple contexts, and that technologies such as a piece of software can be reused in solutions. Remember that the principle of architecture is to be able to be used, right? So for the replicability, it has the benefit that best practice on solving a particular type of problem can be reused. Basically, it does not mean the source of the devices, the system layout can also be reused. An example in activity pattern and a solution proof have some more explanation of replicability. But for these two concepts, interoperability and replicability, they are quite straightforward. For the standardization, actually there are three different processes we can achieve. So we have the standards, organizations, open source, and also industry alliance. Yeah, these three entities are easy to understand. For standard development organizations, they define formal standards that are mandated for use. Some examples here. I think the ISO is the most familiar to you. And we also nowadays, especially for the software domain, we have the open source model, which is a decentralized development model that builds on open collaboration. So we mentioned decentralized here. The previous one, development organizations, because we only have those organizations. So the decision is made by them centrally. But for open source model, it's decentralized development method. Usually for this type of model, it is used for the source code. Source code means, for example, you use Python or C do some coding to realize some function. For example, you realize a regression function, regression or supporting vector machine function in the Python code. And those codes will, if it is in an open source project, it will be shared to other people. for free. Of course, you can give some tips to the team. And also, they include the blueprints and documentations. They are all openly available. So if you are a programming guy, you should have used resources from the GitHub, right? So actually, I use it quite a lot, especially some questions regarding the programming, the coding. You can find good answers on the GitHub. For the IoT, Open Source Foundation, Eclipse is basically the company related to Java, right? And also for Linux, you know that. And also with alliance and consortium have becoming of growing importance of IoT. So as its name indicates, basically some big names, big guys, industry, they will work together to define the standards. And later on, the standards will be accepted by more entities. So that's also getting popular. So one thing to mention is that these different ways to do standardization are not mutually exclusive or separate. On the contrary, there are different tools that combine to achieve great technical standards. Basically, sometimes through the interaction of the three elements of the three processes. And we also would like to illustrate that standardization around IoT is rather rich and multidimensional. So let's look at this figure here. So actually we can see some alliance there. This bunch of guys there. For the multi-industry, we also have those things. So the first horizontal IoT standards, or as applied IoT standards. So we have horizontal IoT standards and also applied standards. So what do they mean? So applied IoT standards target the vertical or sector, basically buildings, utilities, and energy manufacturing. Basically, it focuses on industry. Manufacturing, it will include raw material supply, and manufacturing processes, post-processing, something like that, focusing on one industry. The horizontal technical standards can be generally applied across a number of different industries. So those are the difference. So the second top level standardization activities define entire systems of parts of systems, and other standards will target development specific pieces of technologies. For example, if now we are using Bluetooth BLT 4.0, I guess. So if they are developing like BLT 6.0 something, they are focusing on a specific protocol, right? But if they would like to build for example, for the whole area, then it is another. So we have the systematic perspective and the enabling technology is a protocol perspective.